Students, in this lecture actually you have to show some type of expressions, and this expression occurs only for the Francis turbine. Okay, now see, we have to show for a Francis turbine the hydraulic efficiency for a Francis turbine having a velocity of flow through runner as constant is given by the relation hydraulic efficiency is equal to 1 by 1 plus 1 by 2 tan square alpha into 1 minus tan alpha upon tan theta. Actually this question were asked in AKTU examination 2018-19. So this question is also important in the exam point of view. Now here this is the velocity triangle for the reaction turbine. As you can see, beta is equal to 90 degree at outlet, Vf2 is equal to V2. Why? Because the discharge is radial at outlet. Now see, actually we have to prove the efficiency is equal to hydraulic efficiency is equal to this expression, where alpha is the guide blade angle at inlet, theta is equal to runner vane angle at inlet. Turbine is having radial discharge at outlet, already told you. If vanes are radial at outlet, then the hydraulic efficiency is equal to 2 upon 2 plus tan square alpha. Okay, as the questions says the velocity of flow Vf1 is equal to Vf2 is equal to constant, and the discharge is radial at outlet, that is Vw2 is equal to 0 meter per second and Vf2 is equal to V2. Now see, from the inlet velocity triangle, what is the value of tan alpha? Tan alpha is equal to Vf1 upon Vw1. Okay, and tan alpha is equal to Vf1 upon Vw1. That's why Vf1 is equal to Vw1 tan alpha. This is the equation number 1. And also we know that tan theta is equal to Vf1 upon Vw1 minus u1. Okay, this is the value of tan theta. Now the value of Vw1 minus u1 is equal to Vf1 upon tan theta, and from this relation we can write Vf1 as Vw1 tan alpha. That's why Vw1 minus u1 is equal to Vw1 tan alpha upon tan theta. This implies that the tangential velocity at inlet u1 is equal to Vw1 minus Vw1 tan alpha upon tan theta. This implies that u1 is equal to Vw1 bracket में 1 minus tan alpha upon tan theta. Okay, this is equation number 2. Now further we know that h minus V2 square upon 2g is equal to 1 by g into Vw1 u1. Okay, now from this relation we can write another expression for net head. The net head capital H is equal to 1 by g Vw1 u1 plus V2 square upon 2g. Actually the V2 square upon 2g is the kinetic head at outlet, and this value becomes 1 by g Vw1 u1 plus Vf1 square upon 2g, because V2 is equal to Vf2 and Vf2 is also equal to Vf1. That's why V2 square upon 2g become Vf1 square upon 2g. Now here, because we have to prove some expression, then for to achieve that expression we have to follow some steps, and further V2 is equal to Vf2 is equal to Vf1, already given in your question. Now H is equal to 1 by g Vw1 u1 plus V2 square upon 2g, and this becomes this, already discussed. I think this line is repeated. Now putting values of Vf1 and u1, then we get H is equal to 1 by g Vw1 u1 into 1 minus tan alpha upon tan theta plus Vw1 tan alpha the whole square upon 2g. And after arranging some terms, as VW1 square is common, and within bracket we got 1 minus tan alpha upon tan theta, and on this term, these two terms, we can take the common VW1 square upon 2g as common. Then within bracket what we get, 1 minus tan alpha upon tan theta plus tan square alpha upon 2. Now because we know that the hydraulic efficiency is equal to VW1 U1 upon GH, runner power upon water power. Okay, VW1 U1 as it is small g, and then put the value of H, and already the value of H is achieved, and that value is VW1 square upon g into 1 minus tan alpha upon tan theta. Okay, now if we have to find out the second expression, like and if the vanes are radial at outlet, then hydraulic efficiency becomes 2 upon 2 plus tan square alpha. एक्चुअली हाइड्रोलिक एफिशिएंसी ये तो प्रूव हो गई, ठीक। अगर ये प्रूव हो गई तो अब रेडियल के लिए हमको क्या करना होगा, रेडियल के लिए हमको क्या करना होगा, we put theta is equal to 90 degree, we put theta is equal to 90, then what happens, 1 upon 1 plus 1 by 2 tan square alpha into 1 minus 0, then the hydraulic efficiency becomes 2 upon 2 plus tan square alpha. ओके, तो इस न्यूमेरिकल में बेसिकली हम क्या किए, हमको ये पता था कि एक ट्रिग्नोमेट्रिक एक्सप्रेशन जो है हमको अचीव करना है, और वो वैल्यू क्या है, tan स्क्वायर अल्फा 1 माइनस tan अल्फा अपन tan थीटा। हाइड्रोलिक एफिशिएंसी ऑलरेडी हम जानते हैं, तो उसको हम क्या किए, tan अल्फा और tan थीटा के टर्म में कन्वर्ट कर लिए। कैसे, यहाँ इस तरीके से tan थीटा और ये फिर tan अल्फा। और चूँकि tan अल्फा और tan थीटा में जब सारी चीज़ें कन्वर्ट हो जाएंगी, तो फाइनली हमको हाइड्रोलिक एफिशिएंसी किस में मिल जाएगा, tan अल्फा और tan थीटा में। सारी वैल्यूज हम कर दिए किस में कन्वर्ट, tan अल्फा tan थीटा। तो इस तरीके से हमको ये एक्सप्रेशन मिल गया, और यहाँ पे ये एक्सप्रेशन मिल गया। ओके, थैंक यू।